go to the next question. Solutions of sodium carbonate and silver nitrate react to form solid silver carbonate in the solution of sodium nitrate. So this is another example of a limiting reagent question. First thing I'm going to do is write out the balanced equation. Then I'm going to do the same thing I did in the other question and just try to separate by the compounds just to see what they give us. The mass of sodium carbonate is 8 grams. Its molar mass is 106 grams per mole. And then if we were to calculate this, find the number of moles, it would only be around 0.075 moles. Then we're going to do the same thing for the silver nitrate. It started off with 4.75 grams. Its molar mass is 170 grams per mole. So its number of moles will be calculated to be 0.0279 moles. So again, let's look at the molar ratios. We need 2 moles of the silver nitrate to react with 1 mole of the sodium carbonate. So already we can see that the silver nitrate is the limiting reagent. Okay, so now I'm going to do the same thing that I did in the previous question to find out the moles of sodium carbonate that's left over. It's going to be however many we started with, so the 0.075 subtracted by however many reacted with the silver nitrate. And then we should get a value 0.061 moles of sodium carbonate left over. To find out its mass, it's going to be 0.061 moles times the molar mass, which is 106 grams per mole. And then we end up with 6.47 grams left over. Okay, so the second part of the question is how many grams of sodium carbonate are left. So sodium carbonate is one of the products that was formed, and it also reacts in like a 1 to 2 molar ratio, but we need to base it on the number of moles of the limiting reagent. So since our limiting reagent is the sodium nitrate, I'm going to write that down. And then I'm going to do my molar ratios. 1 mole of the silver carbonate product is formed with every 2 moles of the limiting reagent. And then we end up with 0.014 moles. So to find out its mass, we're going to multiply by the molar mass, which is 275.7 grams per mole. And then we end up with 3.85 grams. So now let's look at sodium nitrate. You can see that they react in a 2:2 molar ratio, so the number of moles are going to stay the same. So I'm just going to write 0.0279 moles and multiply it by the molar mass of sodium nitrate, which is 85 grams per mole. And we end up with 2.37 grams. And then lastly, the question also asks what's the grams of sodium nitrate left over. So it's just going to be 0 since all of it reacts in the question. So I'm just going to try to fit it at the bottom. Okay, so basically, just to sum it up, the sodium carbonate has 6.47 grams left over. We are able to form 3.85 grams of the silver carbonate, and we're able to form 2.37 grams of sodium nitrate, and the mass of the limiting reagent after reacting is 0. So we can kind of see that our junior tutor did the same thing. So they used way more significant digits for their molar mass, so that's why it's a bit off, but you basically get the same answer of 6.3 grams. And then they calculated the mass just by doing the same thing. They got around 3.75 grams of sodium nitrate. So again, it's just because they have different values of the molar mass, but it's basically the same. 0 grams left over. And then for sodium carbonate, basically similar. But the math looks correct. Okay, so solution is correct. I'm going to see